In this lecture, we discuss about linear combinations with some illustrations. Let us first define what is linear combination. Let V be a vector space and x1, x2, x3 up to xn be n vectors and a1, a2, a3, an are scalars. Then the linear combination of the vectors is given by x is equal to a1x1 plus a2x2 plus a3x3 plus anxn. Here a1x1 is the first linear term, a2x2 is second linear term, a3x3 is the third linear term, and similarly anxn is nth linear term. In this, these linear terms are combined, and so we are getting the linear combination of these n vectors. Let us take some examples on linear combinations. Example 1, let v1 equal to 1, 0 and v2 is equal to 0, 1 be two vectors in R square, so that every vector in R square is a linear combination of v1 and v2. Hence, express 5 minus 2 in terms of v1 and v2. We have to prove that every vector in R square is a linear combination of the vectors v1, which is 1, 0, and v2, which is 0, 1. So let xy be any arbitrary element of R square and a1, a2 are two scalars such that xy is equal to a1 v1 plus a2 v2. Now we have given the value of v1 and v2, so we can substitute its value. a1 into 1, 0 plus a2 into 0, 1. Again, we multiply, we open the bracket. a1 into 1 is a1, a1 into 0 is 0, a2 is 0, a2 and into 0 is 0, a2 into 1 is a2. If we add this to 1, so a1 plus 0 is a1, 0 plus a2 is a2, which gives us a1, a2. If we compare the two ordered pair xy is equal to a1, a2, it means that x equal to a1 and y equal to a2. If we put the value of a1 as x in the first this equation and a2 is equal to y, then xy can be written as x into 1, 0 plus y into 0, 1. Clearly, xy is a linear combination of 1, 0 and 0, 1. So this gives us our first answer of the question. Hence, every vector in R square is a linear combination of 1, 0 and 0, 1. Consider 5 minus 2 is equal to a1 v1 plus a2 v2. a1 is equal to a1 and v1 is already given. v1 is equal to 1, 0 and v2 equal to 0, 1. Again, we multiply with this. a1 into 1 is a1, a1 into 0 is 0, a2 into 0 is 0, a2 into 1 is a2, and this gives us a1, a2. It means that 5 is equal to a1 and minus 2 is equal to a2. If we put the value of a1 and a2 in this equation, then 5 minus 2 can be written as 5 into 1, 0 plus minus 2 into 0, 1. Hence, 5 minus 2 can be written as a linear combination of 1, 0 and 0, 1. Thank you.